Hi, my name is Ned Koch. I am the developer of Warp PLS. I'm preparing this video for as an intro for a workshop that will be conducted on Warp PLS. My friend John Amora will be one of the workshop instructors. I hope you enjoy the workshop. I also want to use this video to talk about how to conduct necessary and sufficient conditions analysis, often referred to by the acronym NCA, with Warp PLS employing conditional probabilistic queries. So here I have a model with several latent variables. So this is the main criterion latent variable in my model, JP, and we have several predictors for this JP variable. Based on the results here, you can see that the variables that influence JP directly are JS, job satisfaction, and OC, organizational commitment. And these other variables, democratic management and availability of comparable jobs, they don't influence JP directly, but indirectly via JS and OC. So if we're going to do a necessary and sufficient conditions analysis with certain target values for JP, I will focus on the variables that influence JP significantly. That would be JS and OC directly. These two do not influence JP directly when JS and OC are controlled for. So let's see how I can do that. So let me go to the option Explore, Conditional Probabilistic Queries. And let me start with calculating a probability that JP is very high. So I will choose the option Latent Variable and JP. And I want to see if JP, which is standardized, is greater than 1.5 standard deviations from the mean. That means that it will be around the top 5 to 10% of JP, assuming a normal distribution. Most variables are not normally distribution, but they are quasi-normally distributed. So if I calculate this probability, I get the probability that JP scores will be greater than 1.5, because they are standardized, will be 6.8%. So here I have, this is an interesting probability to consider. This could be a target. So I want to know the necessary condition with respect to OC, which is one of the predictors of JP, and the one that it most strongly influences JP. This path coefficient is 0.33, this is 0.18, so 0.33, so this is the strongest predictor of JP. So I want to see what is the necessary condition with respect to OC for the probability of JP being greater than 1.5, being 100%. So what I'm going to do is I'm going to copy this, I'm going to paste it here. And what I'm going to do is I'm going to write a value for OC, which I will assume first I will start with OC being above average. And I'll calculate the probability. What is the probability that OC being above average if JP is greater than 0.05. That essentially tells me something important from a necessary condition analysis, and I'll show in a little bit why. So I clicked on calculate probability. So the probability that OC greater than 0 if JP is 1.5 is 85.3%. What I want is a necessary condition, which means I want this to be 100%. So what I'm going to do is I'm going to lower a little bit the value covered by OC to minus 0.5 standard deviations below the mean, so that covers a wider range of OC. So I clicked on it. Now I have 94.1%. So I'm going to go down a little bit more, 0.7. Still not 100%. So I'm going to go to 0.9. Not 100% yet. Let me go to 100%. So OC being greater than -1 standard deviation from the mean means that I'm covering the top 83.4% of OC. So OC being greater than -1 is a necessary condition for JP to be greater than 1.5. Stated differently, OC cannot be too low. That is, it cannot be below in the lower 16% or so, 16.4, 16.6%. So OC cannot be too low for JP to be very high. So in other words, for JP to be at the top 6.8% job performance, and typically one would want to maximize job performance, it's necessary that OC not to be too low, not at the bottom 16.6%. So that's a necessary condition analysis. Now let's look at a sufficient condition analysis. So what I'm going to do is I'll copy this down here and then this one at the top. So now I have in my conditional probability query, I want to calculate or to find out what are the sufficient conditions for JP to be very high. And let's see if OC being above average is enough. No, it's not. The 11% probability that JP being very high will be caused by OC being above average. What I'm going to do is I'm going to change this to JP being above average. And let's see if OC being above average is sufficient. No, it's not, but it's getting close, right? So it's 63.9%. The conditional probability that JP will be above average if OC is above average is 63.9%. Now let's include another predictor. This time I'll include JS. That would make this as a multivariate necessary or sufficient condition analysis. So I'm gonna enter also JS being above average. And let's calculate. Not enough. 70% is not sufficient. So in other words, OC being above average and JS being above average is not enough for JP to be above average. So they're not sufficient. Well, let's consider OC being quite high, above 1 standard deviation from the mean. That brings the percentage to 74, so that's not yet sufficient. But let's see if we change both OC and JS to being high. Let's see if that leads to 100%. Not yet. So let's change to very high for OC, almost 100, and let's change to very high for JS. That gets us to 100%. So if I want to guarantee that JP will be above average, I have to have OC being very high and JS also being very high. Both latent variable scores, I expect them to be greater than 1.5 standard deviations above the mean in this data set for me to have JP above average. So those two together are sufficient conditions for JP to be above average. So there you have it. This is how you use conditional probabilistic queries to explore sufficient and necessary or necessary and sufficient condition analysis. And I hope this is useful. As you can see from this video, it's also other combinations and variations can be explored with conditional probabilistic analysis. So instead of 100% guarantee that a particular variable will be above a certain target, you could have a 90% probability, for example. And for practitioners, that may be, in some cases, enough. And I also hope that you enjoy your workshop, and I wish you all the best, and I wish you have a good experience. I'm pretty sure you will have a good experience with my friend Johnny Amora, who is very knowledgeable about multivariate analysis techniques. Take care.